So this is an evaluative task which is looking at measuring gas volumes, and we start off here with an equation for magnesium carbonate reacting with sulfuric acid. You can see from the equation that the ratio is a 1-to-1, which does come into play later on. You've then got some apparatus which is used to measure the volume of gas produced, and you've got some instructions. Now the first question, he has made a mistake in setting up the apparatus such that the volume of gas produced could not be measured. Identify this mistake. Now the thing is that this part of the apparatus here, it works by displacement, which means that as the gas comes up, it forces the water down, and then the level of the water gives you an indication as to the amount of gas that you've produced. If it works by displacement, you have to have in here something that you can displace, and because this is not filled with water, you can't measure the volume of gas produced by displacement. So the answer here is it works by displacement, and therefore there needs to be water in. So his mistake is that he has not put water in to the apparatus. We've then got the apparatus was corrected, and we've got 50 centimetres cubed of 0.1 mole per decimetre cube sulfuric acid, 0.843 grams of magnesium carbonate. Now the carbon dioxide was given off and the gas was collected into 250 centimetre cube measuring cylinder. This is not particularly relevant. It's telling us the capacity of the measuring cylinder. It's not an indication of a volume that we have collected in there. Calculate the amount in moles of magnesium carbonate used in the experiment. We know that N equals M over M. We have our mass, which is given in the question here. We have our molar mass, which we calculate using the periodic table and the masses of magnesium, carbon and oxygen, and that gives us a quantity of 0.1 moles. The next question is then asking us to calculate the amount of moles of sulfuric acid used in the experiment. Now it's important here to recognise that this is not taken from the ratios. It's a 1-to-1 ratio, but we can't assume that the amount of sulfuric acid used is going to be the same as magnesium carbonate, because usually we find that one reactant is in excess and one is limiting. So in this, we are actually told the H2SO4 data, we're given quantities for the sulfuric acid. So the number of moles is equal here to concentration times volume, concentration of 0.1 and a volume of 50 centimetre cubed. And both of those pieces of data are given to us there in the pink. So the quantity of sulfuric acid used is 0.005 moles. The student used an excess of magnesium carbonate in his experiment to calculate the excess mass of magnesium carbonate that was used. So this is quite straightforward, but in order to get you to the right answer, I've given a detailed explanation. So we need to remember that excess means surplus, we've got too much of it, and limiting is the reactant that limits the reaction. It's the one that is all used up during the reaction. So we know that we've got 0.01 moles of magnesium carbonate. That's how much we've added. Doesn't mean that's how much we used, but that is how much we've added. We know that the ratio of magnesium carbonate to sulfuric acid is 1-to-1. So if we've got 0.1 moles of magnesium carbonate, we would need 0.01 moles of sulfuric acid for it to react fully. We know that we've got 0.005 moles of sulfuric acid. Now this means that if it's a 1-to-1 ratio, we don't have enough sulfuric acid to fully react the magnesium carbonate. This means that the magnesium carbonate is in excess and the sulfuric acid is limiting, because this value here, this 0.005 moles, that's the maximum amount of sulfuric acid that can react, and therefore that's the maximum amount of magnesium carbonate that can also react. Anything extra will be left over. So we've worked out what we can deduce, what we can figure out from this information. Now we know that the number of moles of magnesium carbonate used is 0.005, and since we know that the magnesium carbonate to the sulfuric acid is 1-to-1, we can therefore calculate the moles that we have used. If we know that we've added 0.01 moles to begin with, which we found out up here, we extracted that information from the mass, and we know that we are using 0.005 because that's the maximum amount we can use to react with the sulfuric acid, then we must have 0.005 moles left over. Now this seems to be the answer, but the question is not asking us for the number of moles, the question is asking us for the excess of mass. So here we have to use N equals M over M again. The mass is equal to the number of moles times by the molar mass, which is 0.005 times 84.3, missed that off there, gives us 0.4215 grams. So that would be the answer that would be expected in this part of the question here. Now finish this question and then we'll move on to a separate video for the rest. Show by calculation that the maximum volume of carbon dioxide would be produced is 120. Now this is taken from an A-level specification. This volume would depend on your course. So because here we're using an IB qualification as our example, our volume would actually be slightly less. So we know that volume equals n times by 22.7 if we're working in decimeters cubed. If we're working in centimeters cubed, we convert that into 22700. Number of moles times by the number 22700 will give us a volume of 113 centimeters cubed. That volume would be 120 centimeters cubed if we use a 24 decimeters cubed value, which we use with Cambridge A-levels and with GCSE courses also. And then let's finish this page. The student decided that we would use the same mass of powdered magnesium carbonate, powdered being the operative word here, the bold word. What effect would this have on the volume of the gas collected? Now, because we've got the same number of moles used, we have the same number of moles of product formed. Therefore, we have the same volume of gas produced. There is no difference in the amount of gas. The only difference is that it would produce more quickly because we have an increased surface area with a powder in comparison to a non-powdered reactant. So the mass used isn't changing, therefore the moles used isn't changing, therefore the moles produced is not changing. The volume remains the same. And then finally for this video, when an experiment was carried out, the volume of gas collected at room temperature pressure was 108 centimeters cubed rather than the expected 120. Looking at the percentage error of the volume of gas collected, this is the percentage error of the volume of gas collected. We collected 108, we did not collect 120. So here the error is going to be, what is the actual measured error, 2 centimeters, divided by the measurement that we took, 108, and multiplied by 100 to give us 1.85%. This is assuming that it's a single reading that is taken because it's by displacement, and so you're filling the measuring cylinder to the top and taking only one reading. If you were taking 2 readings, then you would need to look at doubling that error because you would introduce a second error there.